Good morning all. This is Dr. D. Khalandar Basha, working as Associate Professor in the Department of ECE, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I am going to discuss a few programs related to 8051 microcontroller. This is part 1 of 8051 microcontroller. In part 2 we will discuss few more programs. The instructions needed for the program are referred in the textbooks, which is 8051 microcontrollers. Authors are Kenneth J. Ayala and publication is Singe's Learning. The first program we will see here, it is write a program to clear 16 RAM location starting at RAM address 60H. So from the address 60H, we are going to be clear 16 locations, that is 6FH. What are the previous data which is reside in these contents we want to clear. After executing this program, the memory location from 60H to 6FH will be loaded with 00. We'll start the program. First, clear accumulator. This is the data which we want to move into the memory location. The first address we are referring, that we are loading into R1 register with the instruction move R1 comma hash 60H. So the starting address we are loading into R1 register. The next instruction is the number of memory location we are accessing is 16 locations. So we are going to be load 16 memory location, either 16D, otherwise we can write this one as 10H, will be loaded into R7 register. Clear RAM location which is pointed with R1. So the contents of accumulator which we have cleared in the first instruction, now the contents of accumulator is 00. This will be loaded to the memory location. The address of this memory location is loaded into the R1 registers, which is going to give as 60H. So after executing this instruction, the contents of accumulator, which is 00H, will be loaded into the memory location, which is pointed by R1 register, that is 60H location. As we have copied into the one memory location, for fetching the next memory location, that is 61H, so the R1 contents we will be incrementing. So using the instruction INC R1. So now the contents of R1 instruction is 61, 62. For every iteration it will be incremented. So as one transaction is done, the count which you are loaded into R7 register, that will be decremented first. If it is non-zero, copy the data of accumulator into memory location which is pointed indirectly through R1 register. So the next instruction you will write as DJNZ, which stands for decrement the first operand, which is R7. Jump if not 0. If R7 contents is non-zero, go to the loop or go to the label which is given as again. So this loop will be iterated for 16 times. This is the first program. At a glance we will see clear A for clearing the accumulator. Move R1 comma hash 60H, which is the starting address of the memory location, is loaded into R1 register. Move R7 comma hash 16D, otherwise we can write this one as 10H. So the number of memory location which we want to refer as 16. So this 16 decimal or 10H will be loaded into R7. The contents of accumulator will be loaded into the memory location whose address is specified in R1 register to clear the location. For moving to the next memory location, we go for incrementing R1 register. This loop has to be iterated for 16 memory location. For every iteration, we will decrement the count which was specified in R7 register. After decrementing, if R7 is non-zero, the loop will be takes place by moving the control to label with the name again. So this loop will be iterated for 16 times. The next program is write a program to copy a block of 10 bytes of data from RAM location starting from 35H to the RAM location at 60H. So the starting address is 35H and the target address is 60H. From the 35H location, we want to take 10 bytes of data that we want to copy into the memory location, which address is 60H. Now we'll see the program. Move R0, 35H, which is for loading the source address into R0 register. Move R1, #60H. This is for loading the destination address into R1 register. Now the source memory location with the address 35H is loaded into the R0 register, and the target memory location or destination memory location whose address is 60H, it is pointed with R1 register. The size of data which we are going to be transfer is 10 bytes. So either we can write as 10D, otherwise 0AH. This 10D or 0AH will be loaded into a counter register, which is R3 register. Get a byte from the source. This is for retrieving the source contents, which is pointed by R0. So at the rate of R0 will copy the contents of memory location whose address is pointed with R0 register into the accumulator. Next, accumulator contents will be copied into the memory location whose address is specified in R1 register. For every move operation, we have to increment both R0 register and R1 register for referring to the next memory location. As one movement is done, then decrement the count which was specified in R3. After decrementing the R3, if R3 contents are not 0, then go for label 1, and the label 1 is used for copying the data from the source memory location to accumulator, from the accumulator to destination. Now we will see the program at a glance. Move R0, #35H, which is for pointing to the source or source memory location into R0 register. Move R1, #60H, which is for pointing the destination memory location pointed by R1 register. Move R3, #10D. How many memory location we are accessing, that will be loaded into R3 register. Either will be loaded as 10D, that is for decimal 10, otherwise hexadecimal 0AH. Move A, at the rate of R0. The source content which is pointed by R0 register will be copied into accumulator. Move at the rate of R1, A. The source contents which are copied into accumulator will be transferred to the destination location which is pointed with R1 register. For every memory operation, increment R0 register as well as R1 register for advancing to the next memory location for source as well as destination. As one data transaction is done by using this instruction, the count which was specified in R3 will be decremented. So after decrementing R3, if R3 contents are non-zero, the control will be transferred to L1. So this loop will be iterated depending upon the count which was specified in R3 register. Once all the data transactions are done as per the count which are there in R3 register, this control will be terminated and it will become out of the loop. The next program is assume that 5 BCD data items are stored in RAM locations starting at 40H. Write a program to find the sum of all the numbers. The result must be in BCD form. Assume at 40th location we have the data is 71H, 41 location 11H, 42 location 65 is the data, 43 location 59H, 44 location 37H. So here the data is there in this memory location. We are having these 5 BCD values in the memory location 40H. We need to find the sum of all these data numbers After finding out the sum of these data, we have to convert this one into a valid BCD number. First, the address, that is 40H, will be loaded into R0 register by using move instruction. Move R0 comma hash 40H. The number of memory location which we are referring is 5. That will be loaded into R2 registers by using move instruction, that is move R2 comma hash 5. Clear accumulator. Initial sum we are loading into accumulator. This I can take as initial sum, which is loaded as 0 by clearing accumulator. Clear R7 register. This is for loading every time the data. Add a byte which is pointed with R0 register into accumulator. So initial value of accumulator is 0. This will be loaded with the data 1, that is first data, and the result, which is sum, that will be existing. And after add instruction, the data will be copied into accumulator. After addition, whatever the result obtained, if any invalid BCD number is existing beyond 0 to 9, if it is existing, that will be converted into valid BCD number by using decimal adjust. After addition, if any carry is generated, for that we are loaded into R7 register by incrementing. If no carry is generated, go for next label. Suppose if carry is generated, so to take care of those carries, we are going to be increment R7. So after adding the 5 numbers, we are going to have the result in both accumulator as well as R7. How many carries are generated, that will be accumulated in R7 register. Next, for pointing to the next memory location, which is pointed by R0 register, will be incremented by using INC instruction. Increment R0 for advance to the next memory location. The count we have specified in R2. For each addition, the count will be decremented. If the contents of R2 is non-zero, go to the label again. And at the again label, we are going to add the contents of the memory location to the accumulator. So after this, someone will be generated. It will be adjusted decimal. After that, we are going to add D2. So like this, it will be takes place. The final result we can see in both R7 register and accumulator. The program at a glance we can see. Move R0 comma hash 40H, which will be loaded the source address, which is 40H, into the R0 register. Move R2 comma hash 5H. How many memory location we want to access for adding, that count we are going to be loaded into R2 register. For loading the initial sum into the accumulator as 0, so clear the accumulator contents by using CLR A. Move R7 comma A. This is also for clearing R7 register. So this will clear R7 accumulator registers will be cleared. The data which is present at the memory location, which is pointed with R0, that will be loaded into accumulator after addition. The result will be loaded into accumulator. If the result, there is sum after addition, if it is not having any valid BCD number, that will be converted into valid BCD number by using decimal adjust of the accumulator. If any carry is generated, then it will be incremented R7. If no carry is generated, it will be go to the next label. Here for advancing to the next memory location, we go for incrementing R0. As the count is, one addition is done, the count which is specified in R2 register will be decremented, and it will check for whether R2 is 0 or non-zero. If it is non-zero, go to the label again. So for adding the remaining numbers. So this loop will be iterated depending upon the count which was specified in R2 register. The next program is for write a program that finds the number of ones in the given byte. So here we will take the data, assume 8-bit data, that is bit 0 to bit 7. Here we want to find the number of ones in our data. The number of ones we can find by shifting these contents either left side or right side by 1 bit. If you do right shift, then the LSB will be moved to carry flag. If carry is equivalent to 1, increment. If it is 0, no change. Similarly, you can go for shifting right. Both are valid. So when you shift the contents towards left side, this B7 will be copied into carry flag. Here also you'll check for carry flag is equivalent to 1 or 0. If carry flag is equivalent to 1, it indicates the data is 1 in that particular bit. So we are going for incrementing the count. If it is 0, no alter or no change in the data. So as we are taking the data size is 8 bits, the number of times which we are going to be shift either towards left side or right side, which is 8 times. Move R1 comma #0, which is for a counter for finding how many number of ones are there that we are going to be load into R1 register. Move R7 comma #8, because the size of data which we are taking is 8-bit size. So 8 times we have to shift. So that purpose we are going to be load this 8 count into R7 register. Move A comma #97H. This is some example data I am taking randomly as 97H, in which we want to find out how many number of ones are there. That data will be loaded into accumulator. Here we will rotate this contents towards left side either with carry or without carry. It is valid. Rotate left accumulator towards left side. Whenever you are shifting, we will check for carry flag. If there is no carry, go for next label. Suppose if any carry is generated, that indicates the presence of 1. So we are going to be increment the count which we are taking as R1 register. For every iteration, the count will be decremented, which are specified in R7 register. If R7 register is non-zero, again go for again label. In the again label, we are going to be shift the contents towards left side. So the allowed instructions, you can go for either RLC or RL or RR or RRC. Any instruction we can use. At a glance, we can see the program. Move R1 comma #0. This is keep track of how many number of ones are there in the R1 register. So first we are going to be clear this R1 register. How many bits we are going to be checked? It is 8. That will be loaded into R7. R7 will function as a counter. Move A comma data. The data which we want to check how many number of ones are there, that we are going to be loaded into accumulator. So here this rotate contents towards left side either with carry or without carry, either shifting towards left or right with carry or without carry are not allowed. So the 4 possible instructions are there here, either RL or RLC, RR or RC. Rotate this contents towards left side of the accumulator. Then we check for either carry flag is there. If carry flag is there, then go for incrementing the count, which is R1. If no carry is there, directly we'll go for next iteration by checking R7, either it is 0 or not. For every iteration, the R7 contents will be decremented. After that, we are going to be check whether R7 is 0 or non-zero. If it is non-zero, go for the label again. So this flow will be iterated until the count in R7 is equivalent to 0. Next, assume that a register A has packed BCD. Write a program to convert packed BCD into 2 ASCII numbers and place them in R2 and R6 register. So here we are going to take the accumulator contents with some BCD number. As it is a packed BCD, we are going to have 2 numbers, BCD number 1 and BCD number 2. First extract one of the BCD number. This one we have to convert into ASCII. Then we will extract the second nibble or second BCD number. For this we are going to be find the ASCII value. The found ASCII value we are going to be loaded into R2 registers and R2 and R6 register. Either one lower you can move into R2, then upper nibble will be copied into R6. Otherwise, if lower nibble is copied into R6, then upper nibble will be copied into R2 register. The program for this is move A comma #29H. This is 29H is the random data which we are considering, for which we want to find out the ASCII value. Move move R2 comma A. So to have one more copy of the data, now it will be loaded into R2 register. And logical A comma 0FH. So when A content is 29H, when we AND with this one with 0FH, the upper bits will be placed as it is, the lower bits or lower nibble will be cleared. If any bit, some X bit, if you AND with 0, it is going to be result 0. If any bit, if you are AND with 1, it is going to be result as 1. So by applying this principle, 9 AND with F will produce 9, 2 AND with 0 produce 0. So this is the lower nibble is extracted. After extracting this lower nibble, we have to add 30H for converting into ASCII value. So by adding this, we will get 39H that will be loaded into the R6 register. Next, for finding out the ASCII value for upper nibble, the data which is present, a copy into the R2 register, that will be loaded back again into the accumulator. Now the accumulator content is 29H. Now for this 29H, we want to extract only the upper nibble. So we are going to be AND this one with F0H. So AND logical A comma hash F0H. As it is starting with alphabet, it will be preceded with 0. When we AND this one 29H with F0H, 9 AND with 0 will produce 0. 2 AND with F will produce 2. So that is 20H. That data we want to shift towards left side, because this upper nibble we want to make it as lower nibble. That BCD number is only 2, but here we are getting 20. For getting this data as 0 to H, the contents of these bits of accumulator will be shifted towards right side by 4 bits. For every 4 bits, here 0 will be appended, the upper nibble will be copied into lower nibble. So for this, we go for shifting the contents of accumulator towards the right without carry for 4 times. So RRA, 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 RRA. So the purpose of these 4 rotate operation, a shift operation, it is for changing the lower nibble to upper nibble and upper nibble to lower nibble. For getting the ASCII value, we will add the accumulator contents with 30H. So 0 to H is there after rotating. Now we will add 30 for this, which it is going to be produced the ASCII value as 32. This will be loaded into the target memory location, which is R2. Now we will see the program at a glance. Move A comma hash 29H, one of the data, random data I am taking as 29H, that we are loaded into accumulator. The accumulator contents, we are going to have one more copy into R2 registers by using the instruction move R2 comma A. For extracting the lower nibble and the accumulator contents with 0FH, then upper nibble will be cleared, the lower nibble will be present. So for that, we are going to be convert into ASCII either by adding or doing OR operation with 30H, which will produce as the ASCII value for the lower nibble in the accumulator. The ASCII value will be loaded into R6. Then the copy which we are having in R2, it will be loaded into accumulator. For extracting the upper nibble, we are going to be AND logically the accumulator contents with F0H. Then it is going to be extract the upper nibble. For swapping the lower nibble with the accumulator, that is upper nibble placing into the lower nibble place, we will rotate the contents of accumulator towards right side by 4 bits. Then for getting the ASCII value, either we go for add or OR with 30H for the accumulator contents. The retrieved or obtained the ASCII value will be loaded into R2 register as per problem statement. Thank you. These are the few programs related to 8051 microcontroller. In the next session, we will see a few more programs related to 8051 microcontrollers. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.